Hi, and welcome to an introduction to probability. All you need for this is some basic fraction knowledge, basically just how to write fractions and what they mean. Otherwise, it should be fairly straightforward. So basic probabilities. If I roll a normal six-sided dice, what's the probability that I will roll a 6? To work this out, you need to consider two things. How many 6s there are. In this case, there's only one 6. I need to write this as a fraction over basically my total number of options. So by that I mean, how many possible numbers could I roll? In this case, it's a six-sided dice, so I could roll any one of 6 numbers. So it'll be 1 out of 6. Okay, really straightforward, and this will be the same no matter what number this is. If I want to roll a 4, there is still only one 4 on my dice. There's only a total of 6 options. So it will always be 1 out of 6, no matter what number you are rolling. Get a tiny bit harder than that. Next question. Probability I roll a number that is less than 5. So, same idea. We're going to work out how many numbers we have that will be less than 5 on my six-sided dice. Those will be 1, 2, 3, and 4. So I have 4 options. So the six-sided dice, so it's going to be 4 out of 6. Quick aside, here if you want to, you can simplify it to 2 over 3. But for these questions, you don't need to. Both answers will be just as good. Next, what's the probability that I will not roll a 3? The keyword here is not. We want anything except a 3. So my six-sided dice, which numbers are not a 3? That's going to be 1, 2, 4, 5, and 6. So I have 5 options, which are not a 3, which means the odds of not guessing a 3 will therefore be 5 out of 6. Okay, last question, use this dice. Really common trick question. What's the probability that I will roll a 7? Okay, of course this is impossible because there is no number 7 on a six-sided dice. Now answer it 2 ways. You have no options out of 6, that's absolutely fine, or you can just write 0. Both of them mean the same thing, both of them are just as good. So anything that seems impossible, make sure you just write it as 0 or 0 out of whatever. Moving on, this is like a standard word question. So, if I take a letter at random from the word clutter, what is the probability of getting a T? So let's zoom in on my word clutter. We want to know 2 things. We want to know, first of all, how many T's we have. Let me just change that. We want to know, first of all, how many T's we have. Really straightforward. I've got these 2 here. So I have 2 T's, and we're going to write that as a fraction over how many options we have. In this case, how many options is how many letters I have. Let's count how many letters in this word. I've got 1, 2, 3, 4, 5, 6, 7. Therefore, the odds of getting a T, if pick a letter at random, is going to be 2 out of 7 because there are 2 T's out of a total of 7 letters. Okay, you have some questions to try. Again, as always, these questions are in the worksheet, which is attached in the video description. Feel free to download that off, pause the video, and give those a try. Okay, I'll go through the answers in 3, 2, 1, 0. Okay, for question 1A, odds of getting a blue marble. I have 2 blue marbles out of 8 altogether. Again, this you are free to simplify. Odds of getting a green marble. Okay. Odds of getting a green marble, there's just this 1 here. So it will be 1 out of 8. Part C, odds of marble number less than 4. Well, less than 4, I have these 3 options, which means 3 out of 8. A marble which is not red, so it can be that one, and it can also be these 2. So again, I've got 3 options, so it is 3 out of 8. Black marble, there are no black marbles, so it is 0 or 0 out of 8. Both of them are fine. a red marble with an even number. So again, work with options. Is this 2, this 4, or this 6? So again, it is 3 out of 8. Question 2. Looking at the word success, take a letter at random. What probability I get the letter S? So same thing as before, we need to work out how many letters are in here total. So I have 1, 2, 3, 5, 7 letters, which means everything is going to be out of 7. If I look at success, there are 3 S's, so it's going to be 3 out of 7. Letter C, there are 2 C's, so 2 out of 7. Letter G, there are no G's, so 0, or 0 out of 7. And lastly, a vowel, so that can either be my U or my S. Okay, let's move on. Moving on to now is going to be a few probability rules. There's going to be 2 basic rules. First things first, probabilities of a group of events must always add up to 1. So here, I'm grabbing a marble out of a bag. I know the odds of getting a red, I know the odds of getting a green, but I don't know the odds of getting a blue. However, we know there are no other marbles, which means all these numbers must add up to 1. So if I add up these 2 numbers together, 0.2 plus 0.1 gives me 0.3. And to work out what blue is, we're going to do 1 take away 0.3. That gives us 0.7. Odds of getting a blue marble will be 0. Next, we can work out estimates. So here, I've got the question, if I take and replace 20 beads, how many would I expect to get of each colour? Keyword here is replace. Because of putting the bead back in the bag, that means whenever we take a bead out, these numbers aren't going to change. All you need to do for these type of questions is just work out the total number of beads you are taking and then times it by the probability of each colour. So first for red, 20 times 0.2. You work that out on a calculator on your head, that's going to give you 4. And for green, we do 20 times 0.1, that will give you 2. For blue, we're going to do 20 times the odds of getting a blue. Again, we worked this out earlier, and that was 0.7. 20 times 0.7 is going to give us 14. That's all you need to do. Again, you can check your answer. If you add together these numbers, that should always give you your total of 20. Okay, some questions for you to try. Again, in the link in the description, feel free to pause them and give them a try. I'll go through the answers in 3. Okay, question 1. Odds to getting a silver. First things first, we're going to add together the ones we've got. So if I add together 0.15 plus 0.3 plus 0.25, feel free to use a calculator, that will give you 0.7. That means the odds of getting a silver is going to be 1 take away 0.7, which is 0.3. Part B, if I took and replaced 40 beads, how many whites would I expect to get? 40 times by the probability of getting a white. Odds of getting a white is up here, is 0.15. Again, type in a calculator, that will give you 6 beads. Question 2, probability of a bias dice will land on a 6 is 0.25. Clive rolls the bias dice 40 times. How many 6s would he expect to get? Really straightforward. I roll it 40 times. Odds of each 6 is 0.25. Times together, work it out. You're going to find out he would expect to get 10 6s. Okay, so far that shouldn't have been too bad. It's going to get slightly harder now as we are going to move on to sample space diagrams. Okay, so basic problem, or the basic reason we use sample space diagrams is to answer this kind of question. If I roll 2 6-sided dice, what's the odds of getting a total value of 7? What I mean by that, I'm going to roll both my dice, add up the numbers on top, and see if their total is going to be 7. So if I get a 4 and a 3, that will give me a total of 7. So that is what I want. To work this out, we are going to use a sample space diagram. What I need to do, we're going to create a table. And the table size depends on how many options we have. So if I look for each of my dice, I have 6 possible options, which are the numbers 1 to 6. Top, I'm going 1, 2, 3, 4, 5, 6. I'm going to do the exact same thing down the side. And from here, we can now work out every possible option. Basically, this is what I rolled for my first dice, and this is what I rolled for my second dice. Add together all these numbers. So let's fill that in. I'll go through it fairly quickly. I'll just skip to the end. Okay, having done that, you always tend to get a nice little pattern. So something to do to check if you're getting it right. If, for example, I had a 4 here, that would immediately sort of break the pattern for all these 6s in a line. Sometimes you can use that as a clue, check for any mistakes. So, back to the question at hand. What are the odds to get a total value of 7? So, let's work out how many 7s we can get. We're going to do it just like we did at the start. I have 1, 2, 3, 4, 5, 6. I have 6 different ways to get a 7. And that's going to be a fraction out of my total number of options. My options are each of these numbers in here. So if you add together all these numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on and so forth, you will get a total of 36. That is the odds of getting a 7. This, of course, we can, but we don't need to. Simplify this down to 1 out of 7. Okay, now we've got a sample space diagram, we can use it to solve similar questions. What I'm going to do for these questions here, I'm just going to copy my sample space diagram from before. There we go. I'm going to use this to answer these 4 questions. So I need to work out the probability of rolling 2 dice, add them together, and getting a total of 10. So looking on my sample space diagram, there are only 3 10s on it. So odds of getting a 10, I have 3 10s out of a total of 36. So again, just like before, for this entire question, there will always be something out of 36 because there are only 36 options. Part B, a total less than a 5. So less than a 5, that could be a 4, that could be a 3, and that could also be a 2. I have no other numbers, no other options. It gives me 1, 2, 3, 4, 5, 6. 6 options out of 36. And again, with both of these you can, but you don't have to. You can simplify these down to 1 out of 6 and 1 out of 12, but you don't need to. Part C, we want an even number. Let's just erase these quickly. That could be a 2, that could be a 4, that could be a 6, 8, 10, or 12. What you need to do is add all those together. If you do that, you will get a total of 18 out of 36, which is a half, which is what you kind of expect. Lastly, part D, slightly harder. We want a total which is a square number. Square numbers you should know. They're numbers you get from times in a number by itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So we're looking for these numbers here because they are my square numbers. So let's see if we can find any of them on here. Yeah, I've got 4. 4 is a square number. There's no 1s. I've got some 9s. 9s are square numbers. And there are no 16s. And anything else, 5 times 5 will be bigger than this, so also won't be on my list. How many square numbers do we have? We have 3 here and 4 here, to a total of 7. And that'll be 7 out of 36. Okay, some questions for you to try here. As always, I'll go for the answers in a few seconds and I'll pause the video. 0. Okay, for questions 1 to 5, that's all I'm going to go through. We're going to want a sample space diagram, add them together, 2 numbers on a 4-sided dice. Same as before, just a bit shorter, a bit more straightforward. We're going to work out probability. We added the sum as a 6. We have 3 6s, and there are a total of 60 numbers here in red, so 3 out of 16. Less than 4, that's going to be any of these numbers. That is also 3 out of 16. A square number, remember from before the square numbers are 1, 4 and 9. The only square number in this sample space diagram is 4. So again, that is 3 out of 16. And lastly, the odds of getting an even number on even numbers are 2, 4, 6, and 8. And there are 8 of them, so that'll be 8 out of 16. You can simplify to a half, but you do not need to. Question 5, what total are you most likely to roll from adding 2 4-sided dice? So I want to zoom in on my sample space diagram and see which number comes up the most. In this case, the most popular number is a 5, so I'm most likely to get a 5. Okay, that's it. Hopefully it wasn't too bad for you, and as always, thanks for listening.